Good morning, students. This is Math 2008, and today is June 15th. Your exam is on Tuesday, next class. Basically, we don't meet on Friday. It's Friday, Saturday, Sunday, Monday is a holiday, and your exam is on the 20th of June. Um, so make sure you take it on that day. The exam will be available for all day, June 20th, but you will get only 2 hours to take the exam. The sections that will be covered are 2.1, 2.2, 4.1, 4.2, 4.3. We will work on 4.3 today. Please read it very carefully. It's available. It will be available in the Pearson MyLab math assignment area. How do you get there? You click the student link and you go to MyLab math assignments. And it says mock one. You can take it if you want, but it'll be appearing right here. Okay. It'll say exam one. Take exam one. It'll be available for one day. Now let's get to our class today. And let me see. I have students who asked me to do a problem from 1.2. So I'm going to start with that. So basically, what this says, assume the patterns are built on square tiles, built of square tiles, and the pattern continues. How many square tiles are in the sixth shape? This is, I have one, two, three, four, five, the sixth one. So what I see, guys, the way I see it, that each shape is a square plus a tail. This is the tail, all right? This is the tail. This is the tail. This is the tail. So each shape is nothing more than a square and a tail. Now you might say the first one doesn't have a tail. I'll say it has a tail that's 0 units long. Okay. So the first one is a 1 by 1 square, 2 by 2 square, 3 by 3 square, 4 by 4 square, 5 by 5 square. The next one has to be, I'm going to write a subscript 6. The sixth shape must be 6 by 6 square. Just going to write 6 square. Now, how do we address the tail? Okay, the first one has a tail that's 0 units long. The second one is 1 unit. Third one is 2 units. The fourth one is 3 units. The fifth one is 4 units. So this one must have a tail that's 5 units long. And that's all there is to it. 6 times 6 is 36 plus 5. And I'm getting 41 if I'm not mistaken. Okay, now I'm gonna check in a nice way. I'll show you how to check it. Now I'm gonna do part B. This is part A. Part B is very similar. The nth term, the nth term of the pattern will be clearly the square will be n squared, and the tail will be 1 unit less than n. And that's all there is to it. A good way to check it is use your formula to find, let's say, the fourth term. This is the fourth term, okay? According to my formula, fourth term should be 4 squared, 4 squared plus 4 minus 1, which is 4 squared is 16, 16 is 15, 15 plus 4 is 19. Now let's count. I have exactly 19 squares here, so I'm right. I can see it, 16, 17, 18, 19. So my formula is probably correct. It is correct. Okay. Now, how do we find the last part? How do we work on the last part? Is there a figure that has exactly 1259 square tiles? Let's do it. That's a good one. So I'm going to take this. I'm going to say maybe there is one. So I'm going to set this up as an equation. Set this up as an equation. Okay. Now I can add 1 to both sides. I can add 1 to both sides and I'll get this 60. And what do I have here? What do I have? Let me put it here beneath the room. I have this. Now I have to do a little bit of work, guys, here. And this, it's a very nice problem, actually. I have to factor out n, and I get n plus 1. Now, what I'm going to do is I'm going to find, look, n has to be a whole number, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So can I find, and what kind of whole numbers are this? N and n plus 1. They're consecutive whole numbers, okay? 5 and 6, 7 and 8, 9 and 10, 11 and 12. Okay, so I'm going to try some consecutive whole numbers and see if I can get 1260, and I will need my calculator. Okay, so 1260. You can guess and check, but I'm going to try, let's say 30, 32. 32 times 33. So I get 1260. No, let's try 34 times 35. 34 times 35. I don't get 1260. I'm getting there though. Okay. 35 times 36. Oh, I got 1260. So n, the smaller one, has to be 35. Now, it's a nice technique, guys. If you don't hit it, if you don't get it, and you did 35 times 36, you got something a little bigger, then the answer would be no, there isn't one. But now there is one. So I would say n has to be 35 because 35 times 35 plus 1, which is 36, is 1260. So I'm going to say n is 35. It's a nice problem. Okay, so I had actually two students who asked me to do it. So you have it. Hope that helps. And now we're going to go back and wrap up 4.3. 4.3 is included in your 4.3 is included in your exam one. All right. So, guys, we are going to talk about GCD or GCF and LCM. Okay, GCD means greatest common divisor, and it stands for greatest common divisor. Divisor is something that divides. We have studied that in 1.2 and 4.1 and 4.2. Greatest common factor and GCD are the same thing. I tend to use the term GCD of two whole numbers, A and B. No, okay. So basically, of course, you can read it. The greatest common divisor or the greatest common factor of two whole numbers, A and B, that both zero, is the greatest whole number that divides A and B. All right, so let's see what it means. So let's say I want you to find the GCD of 12 and 16. Okay, so find out what numbers divide both. 1 divides both, 2 divides both, 3 divides only 12. 4 divides both. 4 is the greatest, largest number that divides both. So the GCD of 12 and 16 is 4. Now, to find the GCD of two numbers that are a bit bigger, we try to express each number as as a prime factorization or as the prime factorization. So so we're going to do that. So let's say I want you to find the GCD of, let's say, 240 and 320. I want you to find the greatest common divisor of these two numbers. So I'm going to show you the steps, okay? So I'm going to do prime factorization as follows. 240 is 24 times 10, but neither one is primes. But 10 is 2 times 5, and 24 is 3 times 8. Now, things are looking much better. 3 is a prime, 2 is a prime, 5 is a prime, 8 is not a prime, but I do know 2 to the power 3 is 8. I might as well write that. Now, instead of 2 to the power 3 times 2, I can write 2 to the power 4. And I like to write things, and I'm actually done, but I like to write things in ascending order. So basically, 240 is this, 2 to the 4 times 3 times 5. Let's do the same thing for 320. 320 is 32 times 10. Well, none of them is a prime, but 10 is 2 times 5, and 32 is 4 times 8. Now, 4 is 2 to the power 2, 8 is 2 to the power 3, so this will be 2 to the power 5, if I'm not mistaken. I think that's about right. Now, there is another 2 here, so I'm going to write 2 to the power 6. And that's my prime factorization of 320. Now, I'm going to check it on my calculator just to make sure I didn't make a big mistake. Okay, the second one is correct, and the third one is correct too. So how do we find the GCD? Now that we have prime factorization of the two, let's put them here. Okay, now you're looking for common ones, and you're going to pick the smaller one. Okay, so this is, these two are common, and these two are common. Okay, I'm going to pick this, and they have the same power. Okay, if they had a different power, I'll pick the one with the smaller one. So I'm going to pick this. So basically the GCD will be 2 to the power 4. So let me do it like this. Is 2 to the power 4 times 5. And I'm going to use my, well, 16 times 5. I think that's 80. 2 to the power 4 is, or 16. It's 80. I'm pretty sure. Of course, you can double check. Now, clearly, 80 is 80 divides 240, and 80 divides 320. And trust me, this is the largest number you could find that'll divide both. Okay, so that's that. Not too difficult. There are tons of examples done in your book. On the exam, I will ask you to find GCD. Um, it'll tell you to find it in a particular way on the exam, but you can do it any way you want. There are a couple of methods discussed in your book, but the one I shared with you is I think it's the most clear, and it's illuminating. So it's probably the best method. And you can look at some other methods, no problem, but I like this one the best. Now we're going to move on to LCM. Okay, the least common multiple of two non-zero whole numbers, A and B, is the least non-zero whole number that is simultaneously a multiple of A and a multiple of B. Remember, guys, what multiples are? Multiples are like 8 is a multiple of 4 because 4 times 2 is 8. 20 is a multiple of 10 because 10 times 2 is 20. So it's the least common multiple. Let me grab the same example if you don't mind. I'm going to find now GCD. I'm going to find LCM. Well, let me give you a basic example, then I'm gonna come back and actually work on the same problem, not the same problem, but okay, so LCM, lowest common multiple. So lowest common multiple of these two numbers. How do we find the lowest common multiple of 15 and 55? Well, I actually grabbed a uh, difficult example, but let's work on it. Okay, so how do we find it? 15, let's express 15 uh, as 3 times 5. And the good news is they're both prime. And 55 as 5 times 11. Now, the lowest common, to find the lowest common multiple, we take the term with the highest power that's common. So here, 5 and 5 are the same. So I don't have to LCM of 15, comma 55. I'll show you one more example, okay? So it's going to be 3. There's only one factor, 3 times 5. I have 5 to the 1, 5 to the power 1. I'll take it only once. If I had 5 to the power 2 and 5 to the power 1, I'll pick 5 to the power, I'll pick the bigger one. And that is 55 times 3. I believe it'll be 165. Let me double check. That's right. Now I'm going to prove to you using my calculator that this is 165 is a multiple of both 15 and 55. It's, of course, it's the lowest one, but let me go back. The computer is acting a little funny, but not a big deal. All right, guys. So 165 is what I got, okay? Using that method, 165. Is it divisible by 15? Yes. And is 165 divisible by 55? Yes. So we're good. So that's correct. Now, how do I know it's the lowest? I really don't. That technique that I showed you, it doesn't, but the way I did it, it is the lowest common multiple, okay? You will not find a common multiple of 55 and 15 that's smaller than 165. So let me go back and do something a little more complicated, okay? Grab the example from the previous slide. Now I'm finding the LCM, okay? Lowest common multiple, LCM, of these two numbers. Now I have my prime factorization, so why do it again? All right, that ought to do it. So I am going to find the lowest common multiple of 240 and 320. Just like before, just like when we found the GCD, you want to find the prime factorization of each number. Now, this time around, you're going to include everything. If the bases are the same, you're going to take the big one. If something doesn't match, you're going to include it. If something matches and they're the same, it doesn't matter which one you take. So the lowest common multiple of 240 and 320 is going to be 2 to the power 6 times 3 times 5. And I'm going to use my calculator to find it, and I'll kind of show you that it is at least a common multiple. So 2 to the power 6 times 3 times 5. 3 times 5 is 15. And 2 to the power 6 times 3 times 5 is 15. 960 is what I'm getting, okay? 960. Now, it is the lowest common multiple, but you want to see if it's a multiple, and I hope it is. We're going to show you. 960 must be divisible by both 320 and 240. 960 is divisible by 320. I hope so, yes. 960 is also divisible by 240. So we're good. That's how you find lowest common multiple. And GCD. Now, GCD and LCM, they have a very nice property, and your book talks about it, and it's something you should know. Okay, so here's the property. Let me show you something interesting, okay? I'm going to tell you what it means in a second, okay? So from the previous slide, I'm going to get GCD. So we did this. There was a reason why we chose the same pair. GCD and LCM of 240 and 320 are the GCD is 80 and the LCM is 960. They have a very nice property. If you multiply 80 by 960, you're going to get the same answer if you multiply 240 by 320. That's all they're trying to say here. So let me go back and test it if it works here for this one. 80 times 960. 80 times 960 is 76,800. And what's 2240 times 360? Sorry, not 360, 320. It's the same number, 76,800. So in this section, let's summarize a little bit. In this section, we would like to, well, we learned how to find LCM and GCD, and it's a very basic section actually. Um, and we used prime factorization to find LCM and GCD. You can use any method you want. Whatever your teacher taught you is good enough for me. And we also learned another interesting property that if you know the LCM and GCD of two numbers, their product would be same as the product of the two original numbers. So that's all I have for today. And this covers 4.3. Make sure you take your exam on time before before the end of the 20th of June. I believe I have like about 20 problems or so, very similar to the homework problems. Good luck, guys. I will see you. The next video will be recorded on Wednesday. Okay. Monday is a holiday. You take the exam on Tuesday. We don't record anything on Tuesday. We are going to record the next session on Wednesday. Good luck, guys, and study. Bye bye.